Okay, this should be the final video over geometric sequence and series. It's going to cover how sigma notation is carried out for a geometric series. So if we look at our sigma notation here, you'll notice that it is written in the form a sub 1 times r to the n minus 1, meaning that that is a geometric sequence. It exactly matches the right side of our geometric sequence equation, except that instead of k we have an n and we have numbers in there for a1 and an. So we're going to approach this in a way that's very similar to the way that we approached sigma notation for arithmetic series. We're going to be using the form of s sub n, where we have a sub 1 minus a sub n times r over 1 minus r. To do that, we need to know three things. We need to know the first term, the last term, and r. So the first term, a sub 1, is going to be when k equals our bottom number. So if we let k equal 3, that is our first term. 4 times 2 to the 3 minus 1 power. Well, that would be 4 times 2 squared, which would be 4 times 4, or 16, would be our first term. Our last term, a sub n, would be when k is equal to our top number. Okay, so our bottom number gives us the first term, and our top number gives us the last term. So 4 times 2 to the 10 minus 1 power. That is 4 times 2 to the 9th, which would be 4 times 512, which would be, what, 2048? 2048. That's going to be our last term. Now, the only other thing that we need to find our series is r. Well, r is even easier to find than n was. It's in the equation. R is equal to 2. So we have everything that we need. We're going to go in and do an arithmetic series equation. A sub 1 minus a sub n times r over 1 minus r. That would be 16 minus 2048 times 2 divided by 1 minus 2. So that would be 16 minus 4096 over negative 1, which would be negative 4080 divided by negative 1, telling us that Sn, the sum, the sigma, would equal 4080. We're going to do a couple more examples just to make sure we have this driven home. So here's the next one. Here we have that r equals 3. If k is equal to 4, then the first term would be 1/4 times 3 to the 4 minus 1 power, or 1/4 times 3 to the 3rd, which would be 1/4 times 27, or 27 over 4. Now that's a pretty nice decimal, but I can't guarantee that the other one's going to stay that nice, so we're going to hold off on converting that to a decimal. The nth term would be when k equals 12. The top number. So that would be 1/4 times 3 to the 12 minus 1 power, or 1/4 times 3 to the 11th, which would be 1/4 times what is undoubtedly a scarily big number. Yep, 177,147. Which is also a pretty nice decimal, so let's just go ahead and convert those to decimals. That would be 44,286.75, and the top one, 27 over 4, is going to be 6.75. And again, r is equal to 3. So we're going to go in and do our sum, which is again A1 minus A sub n times R over 1 minus R. So that would be 6.75 minus 44,286.75 times 3 over 1 minus 3. Now notice I am not rounding anything off ever. We do not round our answers at all. So we do 44,286.75 times 3, which would be 132,860.25. We can also do 1 minus 3 to get negative 2. Then we do the subtraction, so 6.75 minus that number would be negative 132,853.5 divided by negative 2. So then we divide by negative 2, and we get 66,426.75. Do not round it off, period. One more example. So here's one more sigma notation. Again, we have that R equals 4. The number being raised to the power is your R. If we plug in K equals 2, we will get the first term. So 2/3 times 4 to the 2 minus 1 power would be 2/3 times 4, which would be 8/3. That is not a nice decimal, so we're going to have to leave that as a fraction. If we plug in the top number, K equals 9, we will get the last term. So 2/3 times 4 to the 9 minus 1 power would be 2/3 times 4 to the 8th power, which would be 2/3 times 65,536. So we would end up with 131,072 over 3. Again, not a nice decimal, not something we can write the entire thing because it's repeating. So we're going to leave it as a fraction. And your calculator itself may not like that fraction very much. Okay, we have everything we need, so we're going to the series equation, a sub 1 minus a sub n times r over 1 minus r. That is 8/3 minus 131,072 times 4 over 1 minus 4. Now notice that what that does is 131,072 gets multiplied by 4. So we have 8/3 minus 524,288 over 3. And that is over negative 3. Now those have a common denominator already, so we subtract the numerators, and we get that S sub n is negative 524,280 over 3 divided by negative 3. Well, if we're dividing by negative 3, we can keep change flip to do negative 524,280 over 3 times negative 1/3, which would give us negative 524,280 divided by, it would be positive because there's a negative on top and a negative on the bottom. So we do a quick check here to see if that fraction reduces by dividing the top by 3. Hey, it does reduce. So that reduces to 174,760 over 3. Again, we're in Algebra 2. Not all of our numbers are going to work out nicely. We need to be prepared for ugly problems that make us use our math skills. That does it for sigma notation of geometric series.